Imagine a place in the universe so empty and unfathomable that even stars and galaxies stay away. NASA has discovered just such a mysterious nothingness, and this discovery could open the door to unimaginable mysteries. Join us as we delve into the vast expanse of these cosmic voids and discover if they are really leading us on the path to the multiverse. The answer could bring us closer to the true nature of the universe than we have ever dreamed. A hole in the universe. If you look at the night sky, you will see a lot of darkness and thousands of bright stars. If you are lucky enough to look at the night sky outside of cities and urban centers, you will probably see almost as much light, glow, and stars as darkness. Astronomers have long known that the void, or the mysterious dark matter, makes up about 85% of the universe, but they would never have expected the universe to be full of vast areas that contain not even dark matter. These holes in the cosmic matrix should not be confused with voracious black holes. The great voids are millions of times larger than any black hole. Moreover, voids do not have as great a gravitational force as a black hole. They are simply mysterious voids in the cosmos. However, the voids are not completely empty. Here and there wander a few solitary galaxies. But if in other regions hundreds of galaxies appear in a certain quadrant, in an area of the same size in the void, there would be only 2 or 3. The fact that the voids are not completely empty raises further questions. So far, researchers are not able to explain with 100% certainty why there is nothing or very little in these areas. Some theories speculate that it may have to do with the invisible matrix of the cosmos, the filaments, structures in the depths of the universe along which galaxies, stars, and other phenomena move. Apparently, the voids do not have these structures. Respectively, they form inside them in a completely different way compared to the rest of the universe. If these structures are missing, no or almost no galaxy can move in these areas. The current theory is that voids, or cosmic voids, are voids in which, for inexplicable reasons, there is much less matter compared to other regions of the universe. How is the void in space detected? Although the great empty spaces in space have diameters of several million light-years, they are normally not visible to us. Behind and in front of these spaces are numerous galaxies and stars that cover them. Finally, it was a small variation in the temperatures of the cosmic microwave background radiation that revealed the phenomenon. The CMB cold spot in the constellation of Eridanus is about 1.8 billion light-years away and has a diameter of about 1.3 billion light-years. It was discovered in 2004 by a small anomaly in the cosmic microwave background radiation. The discovery was a surprise because the microwave background normally does not show large structures, but is essentially distributed evenly across the sky. But suddenly, a giant structure appeared that was consistently about 0.00015 degrees Celsius below the average of the others. This uniform coldness, albeit small, immediately earned the new discovery the name of cold spot. In the following years, astronomers used special research structures, such as NASA's Chandra Observatory, to further investigate the mysterious cavity. When the X-ray telescope was pointed at the empty space, large portions of void appeared as if this area had been cut off from the rest of the universe. Not a single photon, nothing, was seen. Although the phenomenon of empty space in the universe is a fascinating mystery for us, these appearances are most likely entirely normal. Astronomers may have discovered other such phenomena and, by now, researchers believe that there are numerous empty spaces in the universe. It is possible that they are the direct result of structures that existed at the beginning of the cosmos, shortly after the Big Bang. As the cosmos expanded, it is possible that much smaller empty patches turned into the giants we can measure today. It is important that science understands every single phenomenon of the universe, because only in this way can we discover with certainty how the universe was born and how it will continue to develop. The proof of the multiverse. Around the holes in the universe there are some interesting theories according to which these phenomena are not just any structures. Inside the voids, evidence of the collision of different large void bubbles has been found. Therefore, the cold spot could be a clue to a so-called multiverse. The bubbles that collided here would be different universes or dimensions. The explosion of the collision opened a gap of enormous dimensions in the space-time continuum. The idea of one or more parallel universes is based on the theory of cosmic inflation. This theory states that the universe expanded exponentially in the first fractions of a second after the Big Bang. This expansion could have led to the formation of multiple universes, each with its own characteristics. Another theory suggests that the cold spot is actually the result of a cold, dark gas moving through the universe and affecting the cosmic microwave background. If this were the case, the cold spot could be an important clue as to how the universe will continue to evolve over the next billions of years. Both theories are controversial within the scientific community, and further research will be necessary to determine with certainty whether these hypotheses are true. Cosmic microwave background. The fact that we are able to discover and explore all these things is thanks to the cosmic microwave background radiation. This radiation, audible as a hiss or a constant noise, is a direct relic of the Big Bang and provides a map of the cosmos that shows events very different from the image of a telescope, which can only capture light. The cosmic microwave background was discovered in 1965 by a German-American physicist and astronomer named Arno Allen Penzias. For this revolutionary discovery, Penzias and his colleague Robert Woodrow Wilson received the Nobel Prize in Physics in 1978. In 1964, the two men were working on a large radio antenna at the Bell Laboratories in New Jersey. During this work, the two stumbled upon an annoying background noise that was extraordinarily the same from all directions. For a year, the two scientists searched in vain to find and eliminate the source of the radio disturbance. Penzias stated during the Nobel Prize ceremony, "Most people receive the Nobel Prize for things they were looking for. We got it for something we were trying to get rid of." What started as an incessant and annoying hiss became one of the most important sources of space exploration. Although the radiation is overall very uniform, it shows small differences that scientists study. Researchers will be able to derive more from these data. The Planck mission has been the largest and most accurate mapping of the cosmic microwave background to date. Thanks to these data, researchers have also found the mysterious cold spot. Boots supervoid. The Boots supervoid, or Boots void, is one of the first voids ever discovered. The region, with a diameter of about 300 million light-years, contains only a few galaxies. Their redshift is about 0.05 and corresponds to a distance of about 650 million light-years. The void is named after the constellation of Boots, or Bear Keeper. Naturally, the void is not identical to the constellation, but it is located behind or in front of the numerous stars of the Bear Keeper. In the void itself, there is very little and almost nothing that emits light. The Boots void was already described in 1981, when the American scientist Robert Kirshner conducted investigations into the redshift distribution of galaxies. Redshift is a measure of the speed at which something is moving away from Earth. Due to the way our universe is expanding, galaxies move faster the farther away they are. Using redshift, the team of astronomers led by Kirshner created the first 3D map of the universe. When the map was materialized, a large spherical void appeared 700 million light-years from Earth. On a width of about 330 million light-years there were almost no galaxies. A galaxy like our Milky Way could have fit into this space billions of times. At the time, researchers called this surprising space the Great Nothing. Later, the name Boots void became common. The few galaxies move through space so lonely that entities they're exploring space could look millions of light-years away and there would simply be nothing. Scientists from these worlds might have had the impression, for hundreds of years, that the cosmos consisted of a great void with a single galaxy inside it. After many years and technological advances, these alien astronomers might find another galaxy and rejoice. Only gradually, the alien astronomers would discover that there are regions in the universe teeming with galaxies. Then perhaps they would wonder how such crowded spaces could develop, in the same way that we, on Earth, are amazed that there are spaces of gigantic sizes in the universe where there is almost nothing. Voids as completely normal cosmic phenomena. We must therefore state that voids are, after all, normal cosmic presences that most likely form due to the attraction of the surrounding dark matter. Dark matter normally acts as a cosmic glue that holds together galaxies and surrounding gas clouds. In the void itself, dark matter is not found or is found at much lower levels than in the rest of the universe. Without the gravitational attraction of dark matter, galaxies would move away much faster and, presumably, would move into the great voids. Conversely, voids probably also provide the dark matter clumps in the universe. Ultimately, voids are nothing but appearances of the cosmic landscape, like mountains, valleys, deserts, and seas on our Earth. Research on the underlying structures of the universe is currently in its infancy but offers incredible potential for further and exciting discoveries. Scientists are currently continuing to work to understand the cause of the cold spots and to discover if these mysterious voids can really show us the path to parallel worlds. Do you find the idea of dimensions or even universes colliding in the cosmos and creating great holes fascinating, or do these ideas scare you? Write it in the comments, leave a like, and subscribe to the channel.